All right, let's talk about transformations of functions. So let's use our basic function f of x equals x squared, which is a parabola with vertex at the origin to compare to. So if we wanted to graph f of x equals x squared plus 1, we put a -3. -3 squared plus 1 makes 10. Put in -2. -2 squared plus 1 makes 5. Put in -1. You get 2. Plug in 0. You get 1. Oops, I skipped one. So if you look at the values of y and compare, you can see that the graph will have the exact same shape, only the y values have increased by 1. And the vertex will be at 0, 1. Let's look at the two graphs next to each other. So if you look at the graph of f of x equals x squared, next to the graph of f of x equals x squared plus 1, it has the exact same shape, only the graph has shifted up by 1. All right, let's look at another one. So what do you think will happen if we graph x squared minus 1? Let's put in the same x values. So x squared is 9, minus 1 makes 8. -2 squared is 4, minus 1 makes 3. -1 squared is 1, minus 1 makes 0. 0 squared is 0, minus 1. 1 squared is 1, minus 1 makes 0. 2 squared is 4, minus 1 gives us 3. 3 squared is 9, minus 1 makes 8. So you can see that it has the exact same shape, only now our vertex is at 0, -1. Let's look at the graph of that function. So if we take our basic function and we add 1 to the end of it, the graph will have the exact same shape, only it shifts up 1. If we subtract 1 from the same function, it'll have the exact same shape, only it'll shift down 1. Now let's see what happens if we subtract 2 on the inside of the function. Right, so -1 minus 2 squared is going to be 9. 0 minus 2 squared is 4. 1 minus 2 squared is 1. 2 minus 2 squared is 0. 3 minus 2 squared is 1. 4 minus 2 squared is 4. And 5 minus 2, the quantity squared, is 9. So if you compare it with our original function, we have the same y values, but what's happened to the x values? We can see now that our vertex is at 2, 0. And let's look at the two graphs next to each other. So you see that the vertex is no longer at 0, 0. Now it's at 2, 0. The graph has the exact same shape, only now it's shifted to the right 2 places. So What do you think will happen if we graph x plus 2 squared? Well, let's find out. Negative 5 plus 2 squared is 9. Negative 4 plus 2 squared gives us 4. Negative 3 plus 2, the quantity squared, is 1. Negative 2 plus 2 squared is 0. Negative 1 plus 2 squared is 1. 0 plus 2 squared is 4. 1 plus 2 squared is 9. So we compare this to our original function. We get the same y values, only now our x values are shifted to the left 2 places, and our vertex is at negative 2, 0. So the graph has the exact same shape, only now it's shifted to the left. So changes to the outside of the function will move the graph up and down, and they move the way you would expect. Adding 1 shifts it up, subtracting 1 shifts it down. When you make changes to the inside of the function, we call this counterintuitive in math. It does the opposite of what you might think. When you subtract 2 on the inside, it shifts it to the right 2 places. And when you add 2 to the inside, it shifts it to the left 2 places. Let me write those down. Right, so if you add 1 to the outside of the function, it shifts it up 1. If you subtract 1 to the outside of the function, it'll shift it down 1. If you subtract 2 on the inside of the function, it'll shift it to the right 2 places. And if you add 2 to the inside of the function, that'll shift it to the left 2 places. So from here, you should be able to just look at the function and tell where it's shifted. Let's practice. So if I were you, I would hit the pause button and write down where the vertex of each of these parabolas is, and then we can check. All right. So this is an adding 6 on the outside. That means it shifts up 6. So the vertex goes from 0, 0 to 0, 6. This is subtracting 3 on the inside. So remember, the inside goes the opposite of how you might think. So subtracting 3 means it goes to the right 3 places. If you have 2 things happening at once, then it's just 2 shifts. So the plus 2 on the outside means that it goes up 2. Minus 1 on the inside means that it goes to the right 1. So right 1 up 2 means the vertex is now at 1, 2. All right, remember the inside changes are counterintuitive. So this goes to the left 4 and up 7. This one will go to the right 5 and down 8. And this one goes to the left 8 and down 2. All right, let's look at some other examples. All right, what do you think happens if we multiply by a constant? All right, we have -3 squared. And then multiply that by 2, and you get 18. -2 squared is 4, and then multiply that by 2, and we get 8. -1 squared is 1. Multiply that by 2. 0 squared is 0 times 2. So basically, all of the y values are twice as tall. Some teachers like to say it's stretched vertically, but I prefer to think of it as being a function that increases or decreases twice as fast. So we talked about the average rate of change in the last section. So you have your basic parabola, and then the parabola that's been multiplied by 2, and try to think of the average rate of change between 2 points now. So the average rate of change between x equals 0 and x equals 1 before would have been 1. And now that average rate of change between x equals 0 and x equals 1 is equal to 2. So for this part of the graph where the function is increasing, it's increasing twice as fast. Similarly, for this part of the function where it's decreasing, now that you've multiplied by 2, it's decreasing twice as fast. All right, what do you think happens if we multiply by a half? So you put in -3. -3 squared is 9. Multiply by 2. Put in -2. -2 squared is 4 times a half. -1 squared is 1 times a half. So if you compare our first graph to the second graph, the y values are 1/2 as tall. So let's look at that picture. All right, some people like to say it's stretched this way, but that's not really correct. Think about it this way. Your x values are in the exact same place, but your y values are now half as tall. And in terms of the average rate of change between x equals 0 and x equals 1 for the original graph would have been 1. And now the average rate of change for the same interval is 1/2. So you could say this function is increasing half as fast, or when it's decreasing half as fast. Let me write that down for you. So if you multiply a function by 2, it'll be twice as tall, and then the average rate of change is doubled. All right, so when we took f of x equals x squared and multiplied it by 1/2, then the height is half as tall, and the average rate of change is half as fast. All right, let's do one more shift. What happens if we multiply by -1? So when x is -3, -3 squared makes -9. Is that for now? Negative 2 squared times negative 1 is negative 4. Negative 1 squared times negative 1 is negative 1. 0, 0. So the x values are the same. What has happened to the y values? Well, they're the opposite sign. So the graph will appear to be reflected across the x-axis. So it has the exact same shape. The vertex is in the same place because it's in the origin. That's the only place that would not flip. Otherwise, the vertex will change. And the average rate of change of the function, well, what's happened to it? The average rate of change from 0 to 1 in the original function is positive 1. The average rate of change of the new function is going to be negative 1. So the average rate of change is the same amount, but the opposite sign in this new function. So let's write that down. When you multiply a function by negative 1, its graph is reflected across the x-axis.